It was a Sunday. The boats were out on the lake. Children were playing near the water. And then, without a roar, without a final warning, the sky above the island simply disappeared, replaced by a column of fire and ash 15 kilometers high. In the evacuation that followed, families ran with nothing. No photographs, no documents, no time. They left behind graves, gardens cultivated for generations, a chapel, a school. An entire world buried under ash in a single afternoon. But here is the question that this story refuses to let go of. These families knew. They had always known. They had felt the tremors at night. They had watched the animals grow still before the earth moved. They had heard the elders speak of the eruptions that came before, and they stayed, not because they had nowhere else to go, but because this island, this impossible, dangerous, extraordinary island sitting inside a volcano, inside a lake, inside an island, was the only place on Earth where they truly belonged. This is the story of the people who chose to live inside one of the most active volcanoes on the planet, who built homes, raised children, and buried their dead on ground that could and did erupt beneath their feet. It is a story about the Earth's fury. And about the quiet, stubborn, undefeatable human need to call somewhere home. There are places on this Earth that seem to exist outside of time, places where the land itself is alive, not as a metaphor, but as a truth you can feel beneath your feet. The island of Luzon in the Philippines is one of those places. And within it, there is a lake. Not an ordinary lake. This one sits inside the crater of a volcano. And inside that lake, there is another island. And on that island, people live. This is Taal. One of the most unusual geological formations on the planet, and one of the most dangerous places a human being has ever chosen to call home. To understand why anyone would live inside a volcano, you must first understand the land they were born into. The Philippines sits at the edge of what scientists call the Pacific Ring of Fire, a vast arc of geological tension that encircles the Pacific Ocean, where the great plates of the Earth's crust press and grind against one another in a slow, relentless dance. Nowhere in this arc is the tension more concentrated than in Southeast Asia. Luzon alone hosts dozens of volcanic formations. The ground here is not passive. It is in a constant state of becoming. And Taal, with its lake, its island, and its second crater, is the most dramatic expression of that restlessness. But long before scientists gave it a name, long before maps were drawn, people had already arrived. The Tagalog-speaking communities who settled near Taal's shores did not see a hazard. They saw a home. The soil around the volcano, enriched by centuries of ash and mineral deposits, was extraordinarily fertile. Fish filled the lake in abundance. The water was warm, fed by geothermal energy rising from below. To live beside Taal was, for generations, to live in extraordinary abundance, and some, drawn by that abundance, crossed the water. They stepped onto Volcano Island itself, the small landmass rising from the center of the lake, and they stayed. This is not a story of recklessness. It is a story of a people who read the land in ways that science is only beginning to understand. A story of survival, of devotion,
and of a relationship between human beings and the
Earth that is unlike almost any other on the planet. But it is also a story with consequences, because Taal is not sleeping. It never truly sleeps. There is a word in the Tagalog language, T-A-H-A-N-A-N. It means home. But it carries something deeper than a translation can hold. Tahan speaks of belonging, of roots pressed into the earth, of a place that holds your history, your family, your name. For the families who settled on Volcano Island, that word meant something extraordinary. Their tahanan was the crater of a volcano, rising from the center of a lake in the middle of an island, surrounded by the sea, a home inside a home inside a home, a world within a world. To reach Volcano Island even today, a home in today, you must take a small boat across Lake Taal. The crossing is short, barely 20 minutes from the town of Talisay on the northern shore. But as you move across the water, something shifts. The mainland recedes. The noise of ordinary life fades. And ahead of you, the island rises, dark and low against the sky, its ridgeline scarred by years of eruption and renewal. The water around you is not cold and blue like the open sea. It is warm, faintly sulfurous. A reminder, if one were needed, of what lies beneath. Volcano Island is small, roughly 10 square kilometers in total. It has no rivers, no underground freshwater springs. Rain is collected. Supplies are carried in by boat. And yet, for generations, families built their lives here with remarkable completeness. They constructed homes from local materials, bamboo and wood, raised slightly from the ground, in the practical style common across the Philippine lowlands. They planted vegetables in the mineral-rich soil. They fished the lake. They raised animals. Children were born on the island. Elderly parents died on the island. The rhythms of ordinary life, meals, celebrations, mourning, prayer, all unfolded in the shadow of the crater. The community that made its home on Volcano Island was never a single unified tribe in the strict anthropological sense. It was, more precisely, a collection of farming and fishing families, predominantly Tagalog in language and culture, who had migrated to the island over decades and centuries, drawn by the same powerful combination of fertile land and relative isolation. By the early 20th century, a small but established community had taken root. At its peak, historians estimate that several hundred people called Volcano Island their permanent home. They built a chapel, a small school, a market where goods brought by boat could be exchanged. Life was not primitive. It was simply contained, bounded by water on all sides and by the slow, constant exhale of the earth below. The volcano they lived upon had a history they knew well, passed down not in written records but in the older, more durable medium of memory. Elders spoke of the eruptions that had come before, of the sky turning dark in the middle of the afternoon. Of ash falling like gray snow on the rooftops. Of tremors that rattled the walls and sent the animals into silence. These were not distant legends. They were family stories. Grandparents had lived through them. Some had lost neighbors to the fury of the mountain, and yet they stayed. To an outsider, this choice can seem incomprehensible. Why remain in a place that has already shown it can destroy you? But this question, reasonable as it sounds, misunderstands something fundamental about the relationship between these families and their land. They did not stay out of ignorance. They stayed because leaving meant losing everything that gave life its meaning. The fertile plots of land cultivated over generations, the fishing grounds known only to those who had worked them for decades, the graves of parents and grandparents, resting in the volcanic soil. To leave was not safety. To leave was a different kind of loss. There is something else. Something that science acknowledges but cannot fully measure. The volcano, for the people who lived upon it, was not simply a geological structure. It was a presence, not worshipped. Exactly. These were Catholic communities, shaped by centuries of Spanish influence. But the mountain was spoken of with a particular quality of respect, reverence for something vast and old and beyond human control. The kind of feeling you find in communities around the world who have built their lives at the foot of forces greater than themselves, and who have made their peace with that arrangement. This peace, as we shall come to understand, was always fragile, not because the people were naive, but because the earth, in its long and indifferent life, does not negotiate. It does not warn with words. It warns with tremors and gas, and the slow rising of water in the lake. And sometimes, not always, those warnings come too late. Every volcano has a memory. Not in the way that living creatures remember, not with longing or regret or the bittersweet texture of experience, but in layers compressed into the rock beneath your feet, written in the mineral language of ash and lava and solidified gas, is a record of everything the volcano has ever done. Every eruption, every moment of fury, every long silence in between. And Taal's memory is long, extraordinarily long. Geologists who have studied Taal place its origins at approximately 500,000 years ago. 500,000 years of activity. 500,000 years of the earth opening itself, releasing what had been held under impossible pressure, and then closing again, waiting, accumulating, preparing for the next release. In that vast span of time, Taal has erupted dozens of times, Some of those eruptions were modest, localized, contained, leaving only the nearest landscape altered. Others were of a scale that is difficult to absorb. The original Taal Volcano was, by scientific estimation, a structure of enormous height, a classic stratovolcano rising dramatically from the Luzon landscape. It no longer exists in that form. It destroyed itself. What remains today? The caldera, the lake. The island within is the aftermath of that ancient self-destruction. In geology, this process has a name: caldera collapse, when a volcano expels so much material so rapidly that the chamber beneath can no longer support the weight of the structure above. The mountain does not simply erupt. It implodes. The summit falls inward, creating a vast circular depression, a caldera, that over centuries fills with rainwater, with groundwater. With the slow accumulation of time. Lake Taal is that depression, 60 kilometers in circumference, up to 160 meters deep in places. An inland sea born from catastrophe. And Volcano Island, the small, dark landmass at its center, is what geologists call a resurgent dome. As magma continued to push upward from below in the centuries following the caldera collapse, it lifted a section of the lake floor, gradually above the waterline. The knot erupt into existence in a single dramatic moment. It rose slowly, persistently, the way all things born from the deep earth tend to move, with a patience that makes human lifespans feel like a single breath. By the time the first farming families arrived on its shores, Volcano Island had already been building itself for thousands of years. It was, in a very real sense, a living structure. Still rising, still active. Still breathing. The recorded history of Taal's eruptions, documented since Spanish colonization of the Philippines in the 16th century, is a chronicle that commands respect. Between 1572 and the present day, Taal has erupted at least 33 times. Some of these events were catastrophic. The eruption of 1754 lasted for several months and buried entire towns on the lakeshore, under meters of ash and pyroclastic material. Communities that had existed for generations were erased from the landscape. The eruption of 1911 was more sudden and more lethal. In a single violent episode, a column of steam and ash rose kilometers into the atmosphere. More than 1,000 people perished, many of them on Volcano Island itself, or in the towns along the lake's northern shore. It remains one of the deadliest volcanic events in Philippine history. And yet, after each eruption, people returned. This is perhaps the most revealing detail in all of Taal's human history. Not once, but repeatedly, across centuries, families came back. They cleared the ash. They rebuilt the walls. They replanted the fields. They returned to the island. Historians and anthropologists have noted this pattern, with a mixture of admiration and unease. And speaks to the depth of the bond between these communities and their land, a bond that not even repeated volcanic catastrophe could permanently sever. But it also raises a question that science eventually felt compelled to answer. How much warning does Taal actually give before it erupts? The answer, it turns out, is complicated. Taal is what volcanologists classify as a highly active complex volcano. This means it does not follow a simple, predictable cycle. It does not build quietly for a century and then erupt on schedule. Its behavior is variable. Its eruptions range from slow, effusive lava flows to sudden, explosive phreatomagmatic blasts, the most dangerous kind, produced when rising magma makes violent contact with groundwater or lake water. These phreatomagmatic eruptions can occur with very little warning. The steam they generate expands at extraordinary speed. The ash they produce is fine, enough to travel hundreds of kilometers. And the base surges, dense, fast-moving clouds of hot gas and debris can travel across the lake surface faster than any boat can flee. This is the geological reality beneath the feet of every family that ever built a home on Volcano Island. Not a distant, abstract threat, a present physical condition, the kind of truth that the earth writes not in words, but in rock. And in the lives of those who chose, generation after generation, To remain, there's a particular kind of courage that does not announce itself. It does not carry a weapon or stand before crowds. It wakes before dawn, lights a fire, prepares a meal, and walks out into the morning with the quiet confidence of someone who has made their peace with the world they inhabit. This is the courage of the families of Volcano Island. Not the courage of those who do not feel fear, but the courage of those who feel it completely and choose to remain anyway. By the middle of the 20th century, life on Volcano Island had settled into a rhythm that visitors often described with a kind of reverent surprise. They expected to find desperation, poverty, the hollow-eyed resignation of people with nowhere else to go. What they found instead was something more complex and more moving. They found the community, small, yes, isolated, certainly, but coherent, rooted, alive with the particular warmth of people who depend on one another absolutely. The families on Volcano Island organized their lives around two primary activities, farming and fishing. The soil, as generations before them had discovered, was extraordinary volcanic ash, rich in potassium, phosphorus, and trace minerals, had been deposited across the island for centuries. Roots found purchase easily. Crops grew with a vigor that mainland farmers sometimes marveled at. Corn, sweet potato, and various vegetables were cultivated in small plots carved into the island's gentler slopes. The fishing was equally abundant. Lake Taal is a unique body of water, one of the few lakes in the world where freshwater and marine species coexist, a legacy of its ancient geological connection to the sea. The tawilis, a small, sardine-like fish found nowhere else on Earth, filled the lake in extraordinary numbers. For the island families, this fish was not merely food. It was livelihood, identity, and a daily reminder that their strange and particular home provided for them in ways that few other places could. The community had a social structure as recognizable as any small rural town. There were families who had been on the island for 3 or 4 generations, the old names, the ones who remembered the stories of the eruptions their grandparents had survived. And there were newer arrivals, families who had come more recently, drawn by the land, by a relative already established, by the particular logic of belonging that pulls people toward places where someone they love has already put down roots. A small chapel stood at the center of the settlement. Catholic faith introduced to the Philippines by Spanish missionaries in the 16th century was the spiritual architecture of daily life. Sunday Mass, feast days, the cycle of prayer that marks the seasons of a Filipino Catholic community. The volcano was outside. God, they believed, was within, and for a long time, that arrangement seemed to hold. The children of Volcano Island grew up with an intimacy with the natural world that is increasingly rare. They knew the lake by feel, which currents ran where, which shallows sheltered fish at different times of year, how the water changed color when the wind shifted from the south. They knew the soil by smell, the faint sulfurous edge that reminded you, if you pressed your face close to the freshly turned earth, that this was no ordinary ground. And they knew the sounds, the deep, low rumbles that sometimes moved through the island in the night, the hiss of gas venting from cracks near the crater, the way the birds and the dogs and the horses that some families kept grew still and alert in the hours before the earth expressed itself. This was knowledge, passed from parent to child, not in classrooms but in the daily experience of living. An education that no university offers. But the island was not sealed from the wider world. The boat crossing to the mainland town of Taal took less than half an hour in good weather. Children attended school on the mainland. Young people left for work in the cities, Manila, Batangas, further afield, and sometimes returned, and sometimes did not. The island community was permeable, as all communities are. It breathed in and out, gaining new families, losing others to the gravitational pull of modern life. And through all of this, the volcano continued to do what volcanoes do. It exhaled. Gases rose from the crater. The temperature of the lake water fluctuated in ways that sensitive instruments and sensitive fishermen could detect. Small earthquakes, barely perceptible, rippled through the bedrock with quiet regularity. FIVOLCS, the Philippine Institute of Volcanology and Seismology, maintained monitoring stations around the lake. Scientists recorded data. Reports were written. The mountain was watched, but watching a volcano and understanding it are two different things. And Taal, as it had demonstrated many times before, was not inclined to make itself easily understood. There's a photograph, undated, found in the archive of a regional historical society that shows a group of men sitting outside a bamboo structure on Volcano Island. They are looking at the camera with the relaxed, direct gaze of people who are comfortable where they are. Behind them, the crater rim is visible on the horizon. Above them, an ordinary blue sky. Nothing in the image suggests danger. Nothing in the image suggests that the ground beneath their chairs is the surface of one of the most geologically active structures in Southeast Asia. That is, perhaps, precisely the point. Danger, when it becomes familiar, stops looking like danger. It simply looks like home. There are moments in the life of a volcano that scientists call unrest, not eruption, not silence. Something in between. Period when the instruments begin to register what the human body cannot yet feel, when the data starts to tell a story that the landscape has not yet revealed to the naked eye. For Taal, these periods of unrest are not rare. They are, in fact, part of its nature. The volcano does not simply wait in stillness between eruptions. It stirs. It settles. It stirs again, like something vast and ancient turning in its sleep. To understand what happens beneath Lake Taal during these periods, you must first understand the structure of what lies below, beneath the lake bed, beneath the sediment and the water, and the centuries of accumulated ash. There is a magmatic system of considerable complexity, chambers of molten rock, connected by networks of fractures and conduits, sit at varying depths beneath the surface. Heat rises through these pathways continuously. Water from the lake above, from groundwater, from rain that has filtered slowly downward through the porous volcanic rock, interacts with this heat in ways that are unpredictable and, at times, violent. This interaction between water and magma is the defining characteristic of Taal's eruptive style. It is what makes it so dangerous, and it is what gives the lake its voice. In the years leading up to the 21st century, scientists monitoring Taal observed something that had become a familiar pattern. Periods of elevated seismic activity. Small earthquakes clustering beneath the volcano, alternating with periods of relative calm. Ground deformation. The surface of the island and the lake floor, rising and falling by centimeters, sometimes more, as magma shifted position in the chambers below. Changes in the chemistry of the lake water, increasing acidity, rising sulfur content, fluctuations in temperature that instruments recorded with quiet precision. Each of these signals, taken individually, might mean little. Together, they composed a language that volcanologists were learning slowly to read. But there was another language being spoken on the island itself. One that required no instruments. The fishermen noticed it first. As fishermen often do, the tawilis, that small, irreplaceable fish that had fed generations of island families, began to behave strangely. Schools that had always gathered in certain parts of the lake moved elsewhere without explanation. The water in particular coves seemed different, warmer, or carrying a sharper mineral taste that the men who had fished these waters for decades recognized as something changed. Animals on the island grew restless in ways that defied the usual seasonal patterns. Dogs paced. Horses refused to settle at night. The elders, those who carried the deepest memory of the volcano's previous moods, spoke to one another in the measured, careful tones of people who are not yet certain, but are no longer unconcerned. This intersection of scientific observation and traditional knowledge is one of the most compelling aspects of life in volcanic communities. Modern volcanology, for all its sophistication, is a young science. The instruments that monitor Taal today, seismographs, GPS deformation sensors, gas spectrometers, satellite thermal imaging represent decades of technological development. But the families of Volcano Island had been reading their mountain for generations before any of these tools existed. They had developed, through lived experience and inherited memory, a sensitivity to the volcano's behavior that scientists have increasingly come to respect, not as superstition, not as folklore, as data, observational data accumulated over lifetimes, passed from parent to child, refined by each generation's experience. The kind of data that no instrument can fully replicate, because no instrument has lived here. And yet, for all its value, this knowledge has limits, because Taal's most dangerous eruptions, the phreatomagmatic explosions, the base surges, the sudden violent releases of steam and gas, do not always follow the patterns that memory can anticipate. The volcano is not consistent in the way that seasons are consistent, or tides, or the annual migration of birds. It operates on a time scale that human memory, even across many generations, cannot fully encompass. The 1911 eruption that killed more than 1,000 people came with warning signs that were recognized, but not recognized quickly enough. By the time the danger was clear, there was no longer time to flee. This is the central, unresolvable tension at the heart of life on Volcano Island. The knowledge exists. The warning signs are real. The community's connection to the land is genuine and deep, and still, always. In volcanic geology, there is the possibility of the event that moves faster than understanding. The eruption that does not wait for recognition. The surge that reaches the shore before the boat has cleared the dock. In January of 2020, that possibility became reality. The instruments at Phreatomagmatic stations around Lake Taal had been registering elevated activity for some time. Earthquake swarms beneath the volcano. Slight ground deformation. Modest increases in sulfur dioxide emissions from the crater. Concerning, certainly. But Taal had shown these signs before many times, without producing a major eruption. Scientists were watching. Assessments were being made. On the island, life continued. The boats went out in the morning. The children played near the water. The elders sat in the shade and spoke of what they felt in the ground beneath them, a particular quality of trembling that some of them said they had not felt before, not worse than before. Necessarily different. And in the language of volcanoes, different is the word that demands attention. January 12, 2020 Sunday. In the towns along the northern shore of Lake Taal, families were preparing for the afternoon. Church services had ended. Meals were being cooked. Children moved through the streets with the loose, unhurried energy of a weekend. On Volcano Island, the morning had passed like most mornings. Boats on the water. Smoke rising from kitchen fires. The ordinary sounds of a community living its ordinary life. At 1 o'clock in the afternoon, Taal spoke. It did not begin with a roar. It began with a column, a rising tower of white and gray, steam and ash climbing from the main crater with a speed and force that silenced everything beneath it. Within minutes, the column had reached 1 kilometer above the crater rim, then 2. Then higher still, eventually exceeding 15 kilometers in height, punching through the lower atmosphere and entering the stratosphere. From the mainland shore, people stopped and stared. Some reached for their phones. Some simply stood, unable to move, watching the sky above the island they had seen every day of their lives become something unrecognizable. What was unfolding was a phreatomagmatic eruption, precisely the type that volcanologists had long identified as Taal's most dangerous mode of expression. Magma, rising rapidly through the conduit system beneath the lake, had made violent contact with water. The result was an instantaneous, catastrophic conversion of liquid to steam. Steam that expanded at explosive force. Steam that carried with it pulverized rock, ash, and volcanic gases. Sulfur dioxide, hydrogen sulfide, carbon dioxide in concentrations that were immediately lethal. The eruption column was not merely ash and steam. It was energy, released in a form that the surrounding landscape had no choice but to absorb. Within the first hour, Lightning began to appear within the eruption column. Volcanic. Lightning, a phenomenon produced by the intense friction of ash particles colliding within the plume, illuminated the dark interior of the column in blue-white flashes. It was, by any measure, one of the most visually dramatic natural events in the Philippines in living memory. Photographs and videos taken from the mainland shores spread across the world within hours. Scientists in other countries watch the footage with the particular alertness of people who recognize in what they are seeing a level of geological violence that demands attention. But on Volcano Island, there were no photographs being taken. There was only the eruption itself, close, overwhelming, and immediate. The ash fell not as a distant gray dusting, but as a heavy, suffocating blanket. Visibility dropped to near zero within minutes. Sulfurous gases that had been rising harmlessly from the crater for years now moved across the island in concentrations that burned the eyes and the throat. The ground shook. Science at its best is an act of humility. It is the acknowledgement that the world is larger and more complex than any single mind can hold, that the Earth, with its 4.5 billion years of history, its layered interiors, its slow and incomprehensible processes, does not owe us predictability. It does not owe us warning, and yet we have always watched first with our eyes, then with our instruments, then with satellites orbiting 300 kilometers above the surface, all of us, in our different ways, trying to understand what the Earth is, preparing to do next. Nowhere is this watching more urgent than at Taal, the Philippine Institute of Volcanology and Seismology minus PHEVOLCS is one of the most experienced volcanic monitoring agencies in the world. This is not a distinction that comes easily or without cost. The Philippines sits on the Pacific Ring of Fire with a directness that leaves no room for complacency. The nation has lived with volcanic hazard as a constant companion throughout its recorded history, and that history has taught its scientists something that cannot be learned from textbooks alone. It has taught them respect, not the passive respect of observers maintaining a careful distance, but the active, daily respect of people who understand that the systems they are monitoring are capable, at any moment, of exceeding the boundaries of current understanding. In the aftermath of the January 2020 eruption, PHEVOLCS expanded its monitoring infrastructure around Taal significantly. Additional seismograph stations were installed around the lake's perimeter, increasing the density and precision of earthquake detection beneath the volcano. GPS sensors, capable of measuring ground deformation to within millimeters, were positioned at key points around the caldera, tracking the subtle inflation and deflation of the volcanic system as magma moved within it. Continuous gas monitoring stations began measuring sulfur dioxide emissions from the crater in near real time, because the volume of SO released by a volcano is one of the most reliable indicators of how actively magma is degassing at depth. And above it all, satellites passed overhead on regular orbits, their thermal sensors, scanning the surface of the lake and the island for temperature anomalies, their synthetic aperture radar instruments, mapping ground deformation across the entire volcanic field with a precision that would have seemed extraordinary to the scientists of a previous generation. This constellation of observation, ground-based, aerial, orbital, represents the current state-of-the-art in volcanic monitoring. And it is genuinely impressive. Where scientists in 1911 had little more than their own senses and the reports of terrified residents, their counterparts today have access to data streams of extraordinary richness and continuity. The volcano is watched now in a way it has never been watched before. Every tremor recorded, every centimeter of ground movement logged, every fluctuation in gas output noted and analyzed. But the scientists who operate these systems are the first to acknowledge their limits. Volcanology has advanced enormously in the past half century, and it remains, at its frontier, a science of profound uncertainty. The internal architecture of a volcanic system, the precise location and volume of magma chambers, the geometry of the conduit networks through which that magma moves, the conditions under which pressure will build to the point of eruption, cannot be directly observed. It must be inferred from seismic wave patterns, from ground deformation signals, from gas chemistry, from the behavior of the hydrothermal system. Each of these data streams is a shadow cast by processes happening kilometers below the surface, and like all shadows, they are imprecise. They can tell you that something is moving in the dark. They cannot always tell you exactly what, or exactly when it will arrive. This is the honest condition of modern volcanology. Not failure, not inadequacy. Simply the acknowledgement that the Earth is genuinely complex, and that complexity resists the kind of clean, confident prediction that human beings understandably, desperately want. What monitoring can do, and does, with increasing effectiveness, is narrow. The range of uncertainty. It can compress the window between warning and event. It can give communities the hours, or the days, that make the difference between an orderly evacuation and a catastrophe. At Taal in January 2020, the monitoring worked, the alert levels were raised, the evacuation orders were issued. And while the eruption was violent and the displacement of communities was profound, the loss of life, given the scale of the geological event, was remarkably contained. That is not luck. That is the accumulated labor of scientists, who have spent careers learning to read a mountain. Today, Volcano Island remains officially designated as a permanent danger zone. Entry is restricted. Permanent settlement is prohibited. And yet the monitoring continues, not because scientists expect the island to remain quiet, but precisely because they do not. Taal has shown since the 2020 eruption that it has not returned to a state of simple rest. Seismic activity beneath the volcano has continued at elevated levels. Ground deformation, the slow breathing of the magmatic system, has been recorded in patterns that indicate the system remains pressurized. Phreatic eruptions, smaller explosions driven by the interaction of heat and groundwater, have occurred periodically from the main crater, sending ash and steam into the sky above the lake. The volcano is not dormant. It is between expressions, and the instruments watch it, day and night, with the patient attention of those who know that the next expression may come. Without the courtesy of a long preamble, there is something quietly extraordinary about this vigil. Dozens of scientists and technicians, distributed around the shores of a lake, their instruments pointed at a mountain that most of the world passes by without a second thought. They are, in a sense, doing what the families of Volcano Island did for generations, reading the mountain, learning its moods, trying to understand from the signals it sends what it is preparing to do. The tools are different. The commitment is the same. And the mountain, old, complex, and entirely indifferent to human urgency, continues to do what it has always done. It waits. It stirs. It breathes. And somewhere in the data streaming from the sensors around its shores, the story of its next chapter is already being written. Every story about a volcano is, in the end, a story about time. Not human time, the time of lifespans and generations, of calendars and clocks, but geological time, the slow, patient, incomprehensible time of a planet that has been reshaping itself for 4.5 billion years and will continue long after the last human hand has stopped reaching toward it. To stand at the edge of Lake Taal today is to feel that time pressing against you, not as a threat. As a perspective. The lake is still beautiful. This is the first thing that strikes visitors who come to its northern shore, to Tagaytay, where the ridge above the caldera offers one of the most celebrated views in the Philippines. The water stretches wide and gray-green in the morning light. The island rises from its center, dark and quiet, trailing the faint ghost of a vapor plume from the crater. Around the shores, the towns have rebuilt. The markets are open. Children walk to school past walls painted with murals of the eruption, vivid, unsettling, beautiful. Life has continued, as life does in the presence of the extraordinary. But for the families of Volcano Island, the view from Tagaytay carries a weight that tourists cannot fully share, because what they see when they look at that island is not a landscape. It is a lost world. In the years since the January 2020 eruption, the question of return has never entirely gone away. It has been debated in local government chambers, argued in the pages of regional newspapers, carried quietly and persistently in the conversations of the displaced. Families themselves, some have settled into new lives and towns on the mainland, new homes, new rhythms, a gradual and painful reconstruction of daily existence in places that are safer, but less known. Their children attend school without crossing a lake each morning. Their kitchens look out onto streets rather than water. They are, by any official measure, in less danger than they were, and some have gone back, not with government permission, not with the blessing of FIVOLCs, or the local authorities charged with enforcing the permanent danger zone designation, but quietly, persistently. In the way that people who are rooted in a place return to it when the official attention fades, because the roots have not been severed simply because the surface has changed. This is not defiance for its own sake. It is something older and more difficult to argue with. It is the insistence that a life lived in a particular place, shaped by a particular landscape, cannot simply be relocated to a safer address without losing something essential, something that has no name in the language of disaster. Risk reduction. Something that matters anyway. Not in the subtle, familiar tremors that the islanders had learned to absorb without alarm. And sustained violent convulsions that sent objects falling from shelves and caused the structures of bamboo and wood to creak and shift in ways that suggested they might not hold. The boats. In those first terrible minutes, the boats were everything, the only connection between Volcano Island and the relative safety of the mainland shore. 20 minutes of open water that, under these conditions, had become something far more perilous. Lake Taal was no longer calm. The eruption had sent waves across its surface. Ash was falling into the water, reducing visibility. The air above the lake was thick with particulate matter that obscured the shoreline entirely, and yet the boats went, loaded with families, with children, with elderly parents who could not walk quickly. The small wooden vessels that had carried fish to market and supplies to the island for generations now carried something more precious. They carried everyone who could reach them in time. PHIVOLCS. Raise the alert level to 4 on a scale of 5. Alert. Level 5, the highest, indicating a hazardous eruption in progress, was a designation that the agency's scientists were watching the data carefully to determine. Mandatory evacuation orders were issued for communities within a 14-kilometer radius of the volcano. Tens of thousands of people on the mainland began to move. The roads north of the lake clogged with vehicles. Evacuation centers in Batangas City and surrounding municipalities opened their doors. The Philippine government mobilized with the practiced efficiency of a nation that has lived alongside volcanic hazard for its entire recorded history. And on the island, in the ash and the noise and the sulphurous dark of that Sunday afternoon, the evacuation continued. Family by family. Boat by boat. Some people left with nothing, not a photograph, not a document, not a change of clothes. They left with whoever was beside them. They left because the ground beneath them was no longer the ground they had known. It was something else now, something that even the deepest familiarity, the most practiced reading of the mountain's moods, could not have fully prepared them for. By the evening of January 12th, Volcano Island was empty, or very nearly so, because there is always, in these stories, someone who does not leave, someone for whom the idea of abandoning the tahanan, that word, that deep and untranslatable word for home, is simply not a choice the mind will accept, even when the sky has turned white, even when the ground will not be still. Even then, there is a particular silence that follows a great eruption. Not the silence of peace. Not the silence of an evening settling into night. It is the silence of absence, of a landscape that has been so thoroughly altered that even the sounds that once defined it, the birds, the water, the ordinary human noise of a living community, no longer know where to land. In the days that followed January 12th, that silence settled over Volcano Island, like the ash itself. Thick, gray, absolute. The eruption had lasted through the night and into the following days. PHIVOLCS scientists, monitoring the event from stations around the lake, recorded continuous tremor, a sustained vibration in the earth that indicated magma was still moving. Through the conduit system, beneath the island, lava had emerged from fissures near the main crater. Not in great flowing rivers, as one might imagine from a textbook illustration, but in slow, viscous extrusions, dark tongues of molten rock, pressing through cracks in the crater floor with the unhurried certainty of a force that has nowhere particular to be. The crater lake, that body of water that had sat within the volcano's main vent for decades, had been largely vaporized in the initial phreatomagmatic explosion. Where there had been water, there was now a churning, gas-filled vent, a window, open and raw, into the machinery of the earth. On the mainland, the evacuees from Volcano Island gathered in temporary shelters. School gymnasiums, civic centers, the homes of relatives in towns further from the lake. They arrived carrying almost nothing, and in those first days, sitting on borrowed cots, wearing borrowed clothes, eating food prepared by strangers who had opened their kitchens with the generous instinct that Filipinos call bayanihan. The full weight of what had happened began to settle. The island was gone. Not destroyed, it still stood above the lake, dark and altered and exhaling gas into the pale sky, but gone as a home. Gone as the place they had known. The vegetable plots buried under meters of ash. The chapel, its roof collapsed under the weight of volcanic debris. The fishing boats that had not made it off the island, some found overturned on the shore, some simply missing, swallowed by the altered lake. The graves of parents and grandparents, now covered by a landscape that no longer resembled the one in which those people had been laid to rest. Among the evacuees were people who had lived on Volcano Island for 40, 50, 60 years. Men and women who had been born there, had married there, had raised their children in the shadow of the crater. For them, the loss was not merely material. It was the loss of an entire architecture of memory. The specific tree under which a grandfather used to sit. The particular view of the lake from a kitchen window, seen 10,000 times over a lifetime until it became as familiar as a face. The smell of the soil after rain, that volcanic, mineral, particular smell that exists nowhere else on Earth. These things cannot be carried in a bag. They cannot be replaced in a shelter or reconstructed in a safer location. They are gone. In the way that all things bound to a specific place are gone when that place is taken away. And yet, within days of the eruption, even as the alert level remained high, even as scientists warned that a more hazardous eruptive phase could not be ruled out, something began to happen that surprised no one who understood these families. They began to talk about going back, quietly, at first, in the corners of evacuation centers, in the late hours when the lights were low and the children were asleep, then more openly. When can we return? What is the condition of the island? Is the soil still good beneath the ash? The questions were practical. They were also, in their way, an act of profound resistance. Refusal to accept that the relationship between these families and their island was something that a single eruption, even one of this scale, could permanently dissolve. The Philippine government faced a dilemma that governments around the world have confronted. Wherever human communities exist in proximity to active volcanoes, the science was clear. Volcano Island was not safe for permanent habitation. It had never been safe, in the strict technical sense of that word. But the eruption of January 2020 had removed any ambiguity that might previously have allowed the question to remain open. FIVOLCS recommended that the island be declared a permanent danger zone, that the families who had lived there not be permitted to return, that the tahanan, in the physical, geographic sense, be surrendered. This recommendation did not arrive without compassion. The scientists and officials who delivered it understood what they were asking. They had seen The faces in the evacuation centers. They had heard the stories. They knew that for many of the older evacuees, those for whom relocation to a new place meant the dismantling of an entire identity, this decision carried a weight that went far beyond the practical, but the data was not negotiable. Taal had demonstrated in 14 hours of eruption exactly what it was capable of, and the scientists charged with protecting human life could not, in good conscience, allow that demonstration to be forgotten in the pull of attachment and memory. There is a tension here that has no clean resolution. Between the rights of people to live where their history lives and the responsibility of knowledge, of science, of data, of the hard-won understanding of what this particular volcano is capable of to intervene, between Tahanan and survival, between memory and the future. It is a tension that communities living beside volcanoes around the world, in Japan, in Indonesia, in Italy, in Colombia, have faced and continue to face. And it is a tension that, in the case of Volcano Island, was not resolved by the eruption. It was only made more urgent because even as the ash settled, even as the official declarations were drafted, even as the government began to speak of permanent prohibition and managed relocation, some of the families were already making other plans. The island was still there. The soil under the ash was still the richest they had ever known, and their mountain was once again growing quiet. The scientists at Fuvolks understand this. They do not speak of the returning families with contempt or incomprehension. They speak, more often, with a kind of troubled empathy. The empathy of people who have devoted their careers to protecting lives and who understand, more clearly than most, exactly what the data says about the risk those families are accepting. The volcano is not safe. It will never be safe. In the absolute sense of that word, the next eruption is not a question of if. It is a question of when, and of how much warning the instruments will provide, and of whether that warning will be enough. These are not abstract calculations. They are the terms of a wager being made every day by the families who have returned to the island, a wager they make with full awareness of what they are staking. And yet, when you listen to those families speak of their island, when you hear an elderly woman describe the smell of the soil after rain, or a fisherman explain the particular quality of light on the lake at 5 a.m, something in the calculus shifts, not the science. The science does not shift. It cannot. But the understanding of what is being weighed. On one side, the measurable, quantifiable, incontrovertible risk of living on an active volcano. On the other, the immeasurable cost of a life lived in permanent exile from the place that made you who you are. These are not equal considerations in the language of emergency management, but they are real. And any honest reckoning with the story of Volcano Island must hold both of them. Taal will erupt again. This is the one certainty in a story filled with ambiguity. The magmatic system beneath the lake is active. The pressure is building in the slow and patient way that pressure always builds in these systems, toward another moment of release. When that moment comes, whether in 5 years or 50, whether in a modest phreatic event or something far more violent, the instruments will record it. The alert levels will rise. The evacuation orders will be issued, and the families on the island will face, once again, the choice between the home they have refused to abandon and the safety that exists only at a distance from it. There is a lesson in this story, not a simple one, not the kind that resolves cleanly into a moral or a warning or celebration. It is a lesson about the relationship between human beings and the planet they inhabit. About the depth of the bonds that form between people and the specific, irreplaceable pieces of the earth they call home. About the limits of safety as a complete philosophy of life. And about the volcano itself, ancient, active, beautiful, and dangerous, which does not care about any of this, which simply continues to be what it is. As it has been for 500,000 years. As it will be long after the last boat has crossed the lake, long after the last family has made its last choice, long after the last instrument has recorded its last tremor and the data has been filed away in archives that no one will ever read. The Earth will still be here, still breathing, still becoming. This is Fury of the Earth. If these stories move you, if you believe that the forces shaping our planet deserve to be told with patience, with science, and with deep respect for the human lives caught in their path, then join this community. Subscribe, share this film with someone who still wonders at the world. And stay with us. Because the Earth is never finished telling its story.